Hello everyone, today I Vibhu is going to give you a brief tutorial on QUIC. So this is for those who have a basic understanding of other protocols like HTTP or TCP. First, we will look at the introduction and the need for QUIC, its functionalities, advantages and disadvantages, network applications, security threats, scalability, and much more. First, we have the introduction. As you can see that QUIC is a relatively new transport layer protocol developed by Google. It is designed to provide secure, low latency and reliable communication between clients and servers over the internet. Unlike TCP, which operates over a reliable connection-oriented stream, QUIC uses UDP as its underlying transport protocol, enabling faster data transmission and reduced latency. As in the diagram, you can see that if there is a delay of one RTT, first the client incoates client hello, and if the server rejects, and then it completes client hello in the next step, the data is transmitted, and a server hello is received, and the data is also some data is received. If we have visited a website previously, we can have a zero RTT time, round trip time. So the incoate client hello process is not there, and we directly complete the client hello and send the data, and the server also says hello and sends some data. And QUIC also includes features such as encryption, multiplexing, and flow control, which we will be discussing in detail in the next slides. And as a result of these features, QUIC has become increasingly popular and is now supported by almost all major web browsers and servers. What is the need for QUIC? The need for QUIC arises from the limitations of the traditional TCP. TCP was designed in the 1980s when the internet was very different from what it is today. With the increasing use of mobile devices and the demand for faster, more reliable, and secure connections, TCP's limitations have become more apparent. Also, QUIC addresses these limitations by using UDP, which allows for faster data transmission and reduced latency, and by including advanced features such as encryption, multiplexing, and flow control. These features enable improved performance, security, and reliability, making QUIC an important protocol for modern web applications and services. Now, we will be looking forward to the functionalities of QUIC. Functionalities, some of the major functionalities are like multiplexing, which I said earlier that we are going to discuss in detail. QUIC allows multiple streams of data to be sent over a single connection, reducing the number of connections needed and improving performance. And the second is encryption. QUIC uses encryption to protect data in transit, providing better security and privacy than TCP. The third is the flow control, which is provided by QUIC, that includes flow control mechanisms that prevent overloading of the network and improve reliability. Also, for fast retransmission is a feature for QUIC, and QUIC can quickly recover from lost or corrupted packets, improving overall reliability and reducing latency. Some advantages and disadvantages of QUIC include: first, we will be discussing about advantages. Reduced latency and faster data transmission due to the use of UDP and advanced features such as multiplexing, and improved security and privacy, which we discussed earlier. Also, better performance and reliability through flow control and fast retransmission, and also seamless handoff between different network interfaces or IP addresses. But like every solution comes with its own set of problems. It also has some disadvantages like compatibility issues with some network devices and firewalls, and increased CPU usage due to the encryption and decryption of packets, limited adoption and support, although this is rapidly improving, and at last, complexity in implementation and debugging. So next, we are going to look forward to the network applications, like where it is used in the current scenario. The first network application is the web browsing. Like many major web browsers, including Chrome, Firefox, and Safari, which constitute of like more than 90% of the web browsers that are used daily by the most of the people. In fact, a significant percentage of Google's traffic is now served over QUIC. Second is the video streaming. We like streaming services such as YouTube and Netflix are increasingly using QUIC to deliver high quality video content with low latency. Uh, the video streaming part, I have like explored YouTube and explored it through Wireshark and captured some packets of QUIC, which I will be discussing later in the slides. And the third is the online gaming. Some online games are now using QUIC to reduce latency and improve performance for multiplayer games. Mobile applications. QUIC is also well suited for mobile applications due to its low latency and efficient use of network storage. Here are some security threats to QUIC. First one is the denial of service or DOS attack. Attackers can use various methods to flood a QUIC server with traffic, causing it to become overwhelmed and unavailable to legitimate use. The second one is the man-in-the-middle attack or MIM attack. Hackers can intercept and modify data in transit, potentially stealing sensitive information or inserting malicious code. The third, protocol downgrade attack. Attackers can force the client or server to use an older or less secure version of QUIC or another protocol, making it easier to exploit vulnerabilities. And the fourth is the packet interception and modification. Hackers can intercept and modify QUIC packets in transit, potentially stealing sensitive information or causing errors in the data stream. The timing attacks is the last. In this, attackers can use timing information to infer sensitive information such as the size of encrypted packets or the timing of specified events. The next one, we will move on to the scalability of QUIC. QUIC was designed to be scalable for large-scale deployments on the modern internet. It achieves this by utilizing advanced features such as connection, multiplexing, flow control, and congestion control. Multiplexing allows multiple streams of data to be sent over a single connection. And these details we have discussed already. But the congestion control mechanism and the flow control prevent overloading of the network and improve reliability. QUIC also has features like net connection migration and adaptive rate, which I guess we have a good hold of share of knowledge till now. In the end, we can say that these features make QUIC a scalable protocol that is well suited for large-scale deployments on the modern internet. The Wireshark analysis. In this, I have attached a screenshot of analysis of a website youtube.com, which shows the QUIC analysis. We can do this by like turning on our Wireshark and then logging on to youtube.com. Here I have captured some packets on youtube.com. We will be discussing about these packets in detail now and the process of this handshake and the other processes which occur during this time. The QUIC handshake. QUIC uses a zero round trip time, which means that data can be sent in the first packet itself. In other words, the client can send encrypted data along with the initial packet transmission, which saves time and improves performance. So, like if you go back, you can see that its word initial is written there. It means that we visited this website in a recent time. Like if you visited a website, if you visit a new website that is you have never visited in like some past duration, like 28 days or 28 or something like that, then it doesn't need to make a round trip time for a connection handshake, which means that data can be sent in the first packet itself. Yeah. In other words, the client can send encrypted data along with the initial packet transmission, which will save you both time and the improved performance. This handshake involves the client sending an initial packet to the server, which contains a client hello message with a QUIC version number, a random nonce, and a list of supported cipher suits. You can see the QUIC DC ID there is 62259. Yeah. Then the initial packet transmission. Initial packet transmission Before moving to initial packet transmission, after we send the message which contains the client hello, and the server responds with the server hello message that contains its own random norm, a selected cipher suite, the server certificate. After this, the client sends an encrypted message that includes the session ticket and client's initial data. We can see the server's response in this diagram. Initial packet transmission. The initial packet transmission in QUIC is different from that in TCP. In TCP, the initial packet contains the SYN message or the synchronized message, whereas in QUIC, the initial packet contains the client hello message. This difference is due to the fact that QUIC uses a zero round-trip prime handshake, which eliminates the need for a separate synchronized message. Moving on to the next are the QUIC specific parameters. QUIC has several unique parameters that are used for encryption and flow control. These parameters include the encryption key packet number and flow control window. The encryption key is used to encrypt and decrypt the data sent between the client and server. The packet number is used to ensure that packets are received in the correct order. The flow control window is used to regulate the flow of data between the client and the server. To conclude the QUIC tutorial, we can say that in conclusion, QUIC is a modern transport protocol that offers significant improvements over additional protocols such as TCP and UDP. We have discussed some of its advanced features like connection multiplexing, flow control, and encryption. It also provides reduced latency and improved security and better performance in high congestion networks. And we can see that QUIC has been rapidly gaining adoption by major web browsers, video streaming services, and other network applications, making it a key technology for the future of the internet. As with any network protocol, it is important to be aware of potential security threats, which we have also discussed the disadvantages of QUIC. And overall, we can say that learning and implementing QUIC can be help developers and network administrators to create more efficient and secure network applications that can operate and scale on the modern internet. With this, we are going to end our tutorial. Thank you guys.